Lesson 16.2, Task 1. Graph the basic tangent function. Recall that the tangent of theta equals sine over cosine. All right, and we're going to review looking at the different quadrants, and this just kind of summarizes what the signs are in each one. So remember, your cosine is your x, your sine is your y. Every point along the unit circle is an ordered pair. So this is just a representation of what one of those ordered pairs looks like. So if you have an ordered pair that's in quadrant 1, you know that both your sine and cosine are positive. So that's just saying that sine of theta is greater than 0 and cosine. That's just looking at what these signs are going to be in this first quadrant. This one's going to have a sine greater than 0 and a cosine less than 0. So remember, cosine is your x, sine is your y. So this one's going to be negative, positive. So that makes sense because it goes left on your x's, which is a negative past 0, and then up is positive for sine. All right, so this indicates that in the third quadrant, they're both less than 0. So your signs for the third quadrant would be negative, negative. And in the fourth quadrant, the sine is less than 0 and the cosine is positive, which makes sense because you're going positive x, negative y. So positive x and negative y. Now, why are we reviewing the signs in the different quadrants? Because once again, tangent equals sine over cosine, so y over x. So that means that we need to know what the signs are, because when you divide two positives, you get a positive. When you divide two negatives, you get a positive. But when you have opposite signs, like quadrant 2 and 4, you're going to have a negative sign. So again, this is going to be your y over x, because sine is your y, cosine is your x. All right, so using the coordinates of the point on the unit circle, x and y, cosine of theta, sine of theta, you can find the value of the tangent function from the ratio y over x. The table shows values f of theta equals tangent of theta. All right, so what they've done is they went ahead and done the ratio y over x. So for some angle, you've got negative pi over 2. This is your x value. This would be your y value. So tangent would be undefined at negative pi over 2. And then it would be negative 1 at negative pi over 4, 0 at 0, and then it would be 1 at pi over 4, and undefined again at pi over 2. All right, so it says using the unit circle and the values in the table, what do you observe about the range of the tangent function? All right, so the range is your y values. So what can you determine about your y values? All right, so let's look at the choices. From the values in the table, the range of the tangent function appears to be negative 1 to 1. All right, so it does appear to be negative 1 to 1 because, where's the table? Here we go. So it has a couple undefined, but in between that, it does go from negative 1 to 1. All right. From the values in the table, the range of the tangent appears to be multiples of pi over 2. Well, not just pi over 2. The range is your f of x, or f of theta. So this would be my range. This would be my domain. So your domain may be multiples of this, but not the range. So from the unit circle, there are values of theta for which the ratio y over x becomes very large or very small, which suggests that the range is likely all real numbers. All right, and that is true because your range is talking about your vertical, up and down, your y-axis. All right, from the unit circle, the range is likely all real numbers except 0, and that one is not true. All right, so what appears to be the domain of the tangent function? All right, so the domain appears to be all real numbers except for positive and negative odd multiples of pi over 2. And the domain appears to be all real numbers except for negative odd multiples of pi over 2. The domain appears to be all real numbers including negative and odd multiples of 2. And the domain appears to be whole numbers, but not all real numbers. All right, so the domain again, remember the domain is these values here. All right, so the domain does appear to be all real numbers except for positive and negative multiples of pi over 2. And the reason I say that is because at those values it says undefined, but the rest of those values would be multiples of pi over 2. All right, some values of the tangent function are undefined. What do you think the graph looks like at those values? All right, so we've looked at vertical and horizontal isotopes before. The horizontal isotopes we looked at when we had exponential functions, and we could have looked at vertical isotopes at the same time. I can't remember if we did or not, but anyways, it's going to be a vertical isotope, which means this line is going to approach it, but it's not actually going to get there. So these dotted lines are not actually, that just is an imaginary line. It's not imaginary because you can see it, but you know what I mean. Like it's not part of the tangent function. It just represents that this line is approaching that value. And usually these are graphed on tangent functions to show that, you know, it stays in between those multiples of pi over 2. All right, so the graph of f of x equals tangent of x over the domain negative 2 pi to 2 pi is shown. Recall that x is in radians, and you can see that it's in radians because it says pi over 2, pi, 3/2 pi, 2 pi. So we know that from 0 to 2 pi is the same as 0 to 360, and then this would be 0 to negative 360, but we're using radians, so it's negative 2 pi to 2 pi. All right, what happens to the value of f of x as x approaches x over 2 from the left? So you can see that it's approaching x over 2. So what happens to this function? So let's see. From the right, the value of the function increases and decreases without bound. Okay, so it's not doing both. From the left, the value of the function decreases without bound. From the right, the value of the function decreases without bound. All right, from the left, the value of the function increases and decreases without bound. And from the right, the value of the function increases without bound. And from the left, the value of the function increases without bound. So from the left, it does increase without bound. Okay, so see if you talk about from the left, it goes up and it continues to go up, so it increases without bound. Okay, so if you go from the right, the value of the function decreases without bound. So if you start on the right side of the graph and you go down, starting on the right side, it is going to go down without bound. So that one would be the first one and the last one. And it's all based on which direction you look at it. We normally read from left to right. So when you think about from the left, it's going up, but it does ask you to look at from the right as well. So when you come at it from the other direction, that's what makes it decrease without bound. Does this support your prediction from part B? All right, I forgot what part B was, so let's go see. Has a vertical isotope, so yes, that does match up with what we looked at in part B. Identify the major characteristics of the tangent function. All right, so we looked at the domain and the range. Okay, domain comes from your x values, or this case, your theta values. Range comes from your y values, or your f of theta. The intercepts, you can see where it intercepts the graph. So it intercepts at -2 pi, -pi, 0, pi, and 2 pi. So those would be your x-intercepts. And the y-intercept would be at 0, 0. So it does cross once at 0, 0. All right, increasing and decreasing, we looked at that. So it's increasing everywhere if you read it from left to right. And positive and negative. So the positive intervals would be everything above the the y-axis, and negatives would be everything below. And then the end behavior is definitely increasing without bound as it approaches like each of these isotopes. All right, what is the location of the two vertical isotopes closest to the y-axis? How is the period of the function related to the vertical isotope? All right, so the two that are closest are pi over 2 and -pi over 2. So if you think about that, that's going to be 90 degrees, and that's -90 degrees. And it says, how is the period of the function related to the vertical isotope? So it says two vertical isotopes closest to the y-axis are at pi over 2 and -pi over 2. The period is equal to the distance between these two isotopes because the function has the same shape between each pair of consecutive isotopes. The period of the tangent function is pi. All right, so that's because of your isotopes and because it goes from -half pi to half pi. That's why it equals pi. So basically the period of a tangent function is 180 degrees. 180 degrees is equivalent to pi. All right, is the tangent function odd, even, or neither? Explain. Select all that apply. All right, the function is neither even or odd. The function is symmetric about the origin. The function is odd. The function is even. The function is mirroring about the y-axis. So if we go up here and look at the graph again, okay, so we can see that it does mirror about the origin, which means this would be an odd function. And that also tells us it was symmetric about the origin. All right, that is all for task 1. If you have any questions, please let me know.